Welcome to Digital Electronics EEE 301. This is ASM Mohsin, so I'll teach you this course in this semester. Course material. So here you can see a couple of textbooks, Digital Systems Principles and Applications, Digital Logic and Computer Design, Fundamental of Logic Design. So we'll mostly use first and the last one, but you can check either of them according to our lecture. Learning outcome of this lecture. After completing this lecture, you will be able to describe the functional operation of a basic logic gate using truth table, logic expression and logic waveforms, describe the meaning of a logic family and the operation of the most common technology used today, determine the operating condition of a logic circuit when driving various types of codes, and the implementation of circuits from Boolean expressions. Boolean algebra. Boolean algebra covers operations that we can do with zeros and ones. They are basic building blocks of computation inside digital device. It is a form of expressing relationship between a logic circuit's input and output. Letter symbol might be used to represent circuits input and outputs. For example, the letter A might represent a certain digital circuit's input or output when we must have either A equals 0 or A equals 1. The boolean 0 and 1 do not represent actual number but instead represent the state of voltage variable called logic levels. A voltage in a digital circuit is said to be at logic 0 level or the logic 1 level depending on actual numeric value. Boolean value 0 might be assigned to any voltage in the range of 0 to 1.2 volt and 1 might be assigned to any voltage in the range of 3.2 to 5 volts. Boolean algebra. In digital logic, several other terms are used to represent 0 and 1. So for an example, for logic 0, you can call it false, off, low, no, open switch. For logic 1, it is also known as true, on, high, yes, close switch. Buffer. The first basic gate is the buffer. The output of a buffer is simply the input. The logic symbol, truth table, logic function, and logic waveform from the buffer are given. So this is the typical symbol of the buffer. This is the input and this is the output. So whatever input you give as the input side, you will get the same value at the output. This is the truth table. So we have 0. So at the output we are getting 0. 1 we are getting 1. So this is the typical waveform. Our input is 0, it's falling, and the output input is 1, it's falling at the output. Logic operation. There are three basic operations: OR, AND NOT. Digital circuit called logic gates can be constructed from diodes, transistors, and resistors connected such that the circuit output is the result of a basic logic operation performed on the inputs. Truth table. A truth table is a means for describing how a logic circuit's output depends on the logic level present at the circuit's input. Truth table of two-input logic circuit is like that. So you have the input, which is 2-bit, and you have the output. So for 2-bit, you have 2 to the power n combination. That means 2 to the power n equals 2, so 2 to the power 4 combination. So for 2-bit, you have 4 combination. There are 0, 0, 0, 1, 1, 0, 1, 1. And in the output side you have either 0 or 1. So altogether this is called the truth table. The number of input combination will equal to 2 to the power n for an n input truth table. List of all possible combination follows the binary counting sequence. For example, how many table entries are needed for a 5-input circuit? So n equals 5, 2 to the power 5 equals 32. OR operation. An application example of OR operation is the kitchen oven. The light inside the oven should be turned on. To turn on the light inside the oven, so we have two conditions. Condition A, if the oven light is switched on. Condition B, if the oven door is open. If either of the condition is on, then the light inside the oven should turn on. A and B are combined using OR operation to produce the output X, where X represents the light is on. The output X is a logic 1 for every combination of input values A and B's, where one or more inputs are 1. The only case when X is 0 when both the inputs are 0. OR operation. The OR operation produces a result or output of 1 whenever any input is a 1, otherwise the output is 0. OR gate is a logic circuit that performs an OR operation on the circuit's input. The expression is X equals A or B. This is not plus actually, this is the OR sign, which reads as X equals A or B. OR operation. So this is the typical truth table and this is the symbol. The OR gate looks something like this. So we have two input and one output. So for two input we have to deliver two 4 combinations. So 0 0 0 1 1 0 1 and 4 combination, and this is our output. And from that truth table we can see when either one is 1 or both is 1, then output is 1, otherwise 0. So this is the equation X equals A or B. The plus sign doesn't stand for ordinary addition, it stands for OR operation. OR gate output from timing diagram. Consider you have OR gate something like this. You have two input A and B, and output is your A or B. So you have the waveform of input A, something like this. You have the waveform of input B, something like this. So you need to determine this output. What will be the output? So you know from the truth table, if either one or both is 1, then output is 1, otherwise 0. So here both, from here to here, T0 to T1, A and B both 0, output 0. T1 to T2, A1, B0. So either one 1, output 1. T2 to T3, both are 1, so output will be 1. T3 to T4, A0, B1. Either one 1, output will be high. Similarly, T4 to T5, A0, B0, both 0, output 0. T5 to T6, 1 and 0, so output high. Similarly, T6, 7, output high. So this is the typical truth table of OR gate. Glitch in the output. A glitch is an electrical pulse of short duration that is usually the result of a fault or design error, particularly in a digital circuit. For example, many electronic components such as flip-flop are triggered by a pulse that must not be shorter than a specific minimum duration, otherwise the component may malfunction. A pulse shorter than the specified minimum is called a glitch. It is a short-lived fault in a system, such as a transient fault, that corrects itself, making it difficult to troubleshoot. Here you have given one example. So you have a 3-input OR gate. First consider you have only 2 input A and B, and what will happen? So you have A, you have B, what will happen at the output? So this is typical OR gate. So A 0 0 0 1 and 0 1 1 1 1 and 0 0 0 1 0 1, something like this. So consider you don't have any C now, so you got the output Y. So the glitch may occur when both the inputs are changing their state at a time. So here, if you are suggested to find a glitch, so the trick is you need to locate when both of the input is changing their state. Just locate here, like look at here T1. So at T1 place, A is changing from high to low and B is changing from low to high. So at this particular time, both of the input are changing their state. So that's why in output you will see a glitch. That means for a certain amount of time, you will see output is going low, whether we are expecting high, but for a certain amount of time it is going low. So this is called glitch. Now think about what would happen to the glitch in the output if the input C set in high while A and B are changing at time t1. Okay, so if you have C here, then whether this C have any impact on the glitch, that is the question. So with the C input high at t1, the OR gate output will remain high regardless what is occurring at other inputs, because any high input will keep an OR gate output high. Therefore, the glitch will not appear in the output, so it doesn't really have any impact. So output will be same as previous. Application of OR gate. In many industrial control systems, it is desired to activate an output function whenever any of the several input is activated. For example, in a chemical process, it may be desired that an alarm may be activated when the process temperature exceeds a maximum value or whenever the pressure goes above a certain limit. If either of the condition is going high, then the alarm will turn on. Just an example here. For alarm system, it has one temperature transducer circuit which will produce an output voltage proportional to process temperature, one pressure transducer which will produce an output voltage corresponding to process pressure, and two voltage comparator which will compare both the transducer voltage with the set reference value. Just look at the example. This is your typical alarm system. So you have temperature transducer, you have pressure transducer. This is the comparator which is comparing voltage between Vt and Vtr, and this is your pressure sensor transducer, and this is your comparator which is comparing Vp with Vpr. When either of these values is going above the reference value, then the alarm will be activated, because either this one will be high or this one will be high. There is a more explanation. For temperature transducer, Vt will be compared. So for temperature, Vt will be compared to Vtr, and for pressure transducer, Vp will be compared with Vpr. Both the comparator output will be low, so both the comparator output here will be low at the normal state, but will be switched to high if the temperature, if either of these is high, then the output will be high. The OR gate output will be high or 1, or alarm will be on if either of the comparator output is 1.